Hey, what's going on, guys? Komagigenzi here. I'd like to welcome you all to this new series on how to create a raycasting engine from scratch using Python and pygame. So these are the exact libraries we're going to be using in this series. And in this video in particular, we're going to create, we're going to initialize the pygame window, create the main game loop, and one of the most essential things, will print the two-dimensional board on a half of the screen. Now you might wonder, why do we need the two-dimensional map at all? Because it's kind of like about the pseudo 3D raycasting engine. Now this is the reason why we need this and why this is so important. So there are two kind of types of programmers, I would say: those that are good in math and those that like kind of complete dumps in math, like I am. Okay. And I need to say that before implementing this two-dimensional board drawing to the screen, and before rendering this arrays that we're going to be casting within our scene in the two-dimensional manner, I couldn't really figure out how the algorithm works. However, if you render all the two-dimensional stuff like 2D map, the player, and the race being exposed into the scene from the player's perspective, and just within the range of your field of view, like ray by ray going on there. So when you can visualize this, when you can manipulate this, it's really helpful in terms of understanding what all that sort of math is doing in this raycasting engine. So it's kind of like the visual example of how math is being applied. And even if you don't understand the math completely well, like in my case, let's say, at very least, you can have a visual understanding of how the algorithm works. So it might be a little bit boring at first dealing with this two-dimensional map, but trust me, guys, this is absolutely essential thing, because the entire algorithm, the entire raycasting engine is literally, it's a two-dimensional engine. And then the very last step is just to add the projection the projection plane, and finally we come up with a kind of like three-dimensional illusion, let's say. But really the algorithm itself is really two-dimensional, and it's incredibly important to bear in mind. So first we'll cover all the stuff that regards to the two-dimensional space, and then at the very end we'll add the projection plane to create our three-dimensional illusion. Okay, this is it. So if you're interested, without further ado, let's actually start writing some code. Okay, so first we need to import a few packages. Okay, and I need to say import pygame, the most essential one, then import sys module to be able to escape from the project, and import math, obviously, to make to be able to have an access to sine and cosine functions that we'll need later on. Okay, now let's initialize the pygame on its own. So I can simply say pygame dot initialize. Okay, and now we need to create a game window. So let's say win equals to pygame dot display dot set mode, and now we need to specify the resolution. So I'm using I want the half of the screen to be dedicated to the two-dimensional board, and another half of the screen being dedicated to the 3D projection. So the height of the window would be 480, and multiplied by 2, and here 480. And already we can actually go for specifying some constants here. So actually we can define the screen height. It would be equal to 480. Okay, and screen width is going to be equal to screen height multiplied by 2, and now here we can replace this with screen width, and here with the screen height. Okay, so the next thing to consider, we want to set the window title, set window title, and pygame display dot set caption, and let's just call it Raycasting. Okay, now we need another thing we need to define is the timer. So let's say initialize the timer, and I create the timer like clock equals to pygame dot time dot clock, like this. Okay, and now let's create a game loop. So this is gonna be the main loop. So while true. Okay, and the very first thing to consider is the escape condition. So how can we end the game? So escape condition. So I can say for event in pygame dot event dot get, and if event type, all this is a pretty standard stuff, is equal to pygame dot quit. So literally every pygame project might be done like this. And in this case, well, I want to make some cleanups. So pygame dot quit, and then sys dot exit with this exit status 0, which means that the program completed with no errors. Okay, so are we ready? Yeah, now another thing we need to do, we need to update display. So pygame dot display dot flip, and here we want to set frames per second. So the idea is that if we don't do this, it would be kind of like pressing the button and the character just goes very fast. So in order to avoid that sort of a thing, we need to say like clock tick and then the FPS limit we want. So I'll be using 30 frames per second. Okay, so if I did everything properly, it now should run and show the empty window of the given screen width and screen height. And this lines allows us to, so as long as we click on the close button on window, this makes this fires the quit event, and that's that kind of initializes, and that is forcing our entire program to drop from running. Okay, so Python 3 and part1.py. Let's have a look. Okay, so we got our window. We have Raycasting, not exactly. Okay, I want to say this to Raycasting. Okay, and if I close the window, yeah, window gets closed, and we normally escape from the program, which is absolutely fantastic. Okay, guys, so now let's define the game map. Probably let's do this below the constants. So another constant I want to define is called the map size. Well, literally this is gonna be a map width. So if you have if you don't have the same number of rows and columns in your map array that we'll define just right in a moment, in that case you can call this variable map width, because we'll be using this to calculate the map index using the row and column. So I'll use the value of 8 because I will have the map 8 by 8 elements. So this is our map, and I just make it uppercase because it's a constant and because map is just a keyword in Python, so we can use that as well. And now here is the hack to define string So literally this is the one-dimensional array, 1 2 3 4 5 6 7 8, but as you can see I don't use any commas here, so it's not two-dimensional array, and this parenthesis just allow this fancy string definition. So literally this all is gonna be a single string. I'll show you this just right in the moment. My mom comments, sorry guys. Okay, so yeah, now let's go for 1 2 3 4 5 6 7 8, and here 1 2 3 4 5 6 1 2 3 4 5 6 7 8. Yeah, this is it. This is nice. Okay, so now let's provide some kind of walls here like this. Let's say like here, and maybe like over in here as well. No, it's probably I just want to place the character in the center of the board, so probably let's make it like this, and let's put it right over in here. Okay, yeah, I think this should be just fine. Save. Well, not the cutest map ever, but I think this should be just okay. Now if we just to give you an idea, so if I just print the map, it will print a single string, and also just to give you an idea of the type of the map, so this is just a string map, and yeah, here we go. So you see, like it just prints it as a string, and we have the class string, which means that this is just a string, just a plain string. And just to visually for a better visual representation, I'm presenting this as if it was a two-dimensional array. So I hope it's clear. Okay, this is kind of it, and yeah, so now let's define the function to print this kind of board. So what I want to achieve here, I want the left half of my screen, I want my map to be displayed on the left part of the screen. Okay, so that's the goal, and we can define a separate function for this. So let's say I want to draw a map, so draw map, and here def draw map. So first we need to loop over map rows, and I can say for row in range 8 elements. Okay, and now I'm just checking out if the mic is okay. So we need to loop over map columns. Okay, so for column in range 8. Okay, and now we want to calculate square index. So square index would be, so square equals to, we need to take row multiplied by 8, so multiplied by map size, and plus the column. That's the formula to get the square index from the given row and column. And now we want to draw map in the window, in the game window. Okay, so I can say pygame dot draw dot, I want to draw a rectangle. So it takes first argument is the window to draw the rectangle in, then we want to specify the color. So I want so this is the color for like almost, not almost, well, it's like light gray. It's the RGB values, so R red, green, blue values for pixels. So we want the light, this kind of like walls to be light and the empty space to be dark. So that's how I want to make it. So I can say if, and now we need to take the map indexed by the square. So if it is equal to the wall, in this case we use this light stuff. Okay, otherwise Otherwise we want to have a darker kind of like this thin. Okay, and now we need to specify the parameters of the square itself. So now to calculate so it takes like x, y, and size x, size y coordinates. So I'm not going to be running this, we don't have these variables, but just to give you an idea. Okay, so to calculate these values, we can't use the row and col because the map would be just very tiny. It's not a good idea. So we need to multiply these coordinates by the offset and then use the offset as size x and size y. And now how to get that sort of an offset? So we need to take the half of the screen width, or the screen height in our case. This is okay, so this kind of parameter, and divide it by the map size. And this is gonna be known as the tile size. Okay, so tile size. So just to make it even more didactic, we can take screen width. We want to divide it by 2 because we have we only want kind of the half of the screen, and then we want to divide it by map size, which is equal to 8. Okay, and also want to make this integer because here the coordinates should be not the floating point time, but the integer. So now we can say column multiplied by the tile size, and here row multiplied by the tile size. Okay, and here we have the tile size as the x coordinate, as the x width, and the tile size as the y width. Okay, so yeah, okay, so I think this should be now working. Okay, I just forgot to call the function, but no errors. This is good news already. So here I want to draw two-dimensional board and say two-dimensional map. Sorry, it comes from my chess program background. So draw map, and here we go. Okay, awesome. So we have our map being drawn, but just to make the tiles a little bit more eye-catching, I want to give some bounds there. So I can say tile size -2 pixels, let's say, and -2 pixels like here. Let's have a look. Yeah, now it looks much better, I think. So now we want to draw a player in the very center of the screen. So let's define this. So this would be the global coordinates. Like for our player, it would be like screen width divided by 2 and divided by 2 again, and the same for height. So that's how we get the initial coordinates for our player. Okay, so here we have the constants, and let's just call them global constants, and here we have the global variables. Okay, I'm sorry guys, sorry for not providing classes and outgoing object-oriented approach. I just want to focus on the very gist of the algorithm, and you can always add the object-oriented stuff and wrap this into a class later on your own, so it's not specific to the raycasting in particular. Okay, so we need the coordinates like player X and player Y. Okay, so player X would be equal to let's take this screen width, so to make it as didactic as possible, divided by 2 because we use the half of the screen, and now we want to divide it by 2 again, divided by 2. Okay, and the same for the y coordinate. That's because we have the square map. If this wasn't so, then this would be probably a little bit different. Okay, and now within the draw map, I also want to draw the player. So here we did draw the board, and here we want to draw player on two-dimensional board, and I can say pygame dot draw dot circle, and we want to draw this into the window. Let's make it white. Sorry, let's make it red. So this is gonna be red. Now the coordinates, I want to use player X, and player Y, and the radius is equal to 8. I'm just a bit concerned if this is okay to be the floating point or not. Okay, let's have a look. Oh, just want to close the previous window. Yeah, let's have a look. Yeah, it's because it expects the floating point. So yeah, let's make this guys integers. Okay, like this and like this. Okay. Okay, so yeah, I did something horribly wrong. I told you guys I'm bad in math. So yeah, not the center. Okay, I'm sorry. So let's screen, not screen height. No, in the screen width. Yeah, screen height just multiply by 2. Yeah, screen width. Now this should be fine. Okay, so we got our player in the very center of the screen. Okay guys, so this is it from my side, and in the next video we'll create the core, we'll write the core of the raycasting algorithm on its own. So we'll define the field of view, the rays, we'll be casting the rays like from the player's perspective to the outer world, and when the ray hits the wall, it would drop, and that's the way how to define how to kind of deal with this entire raycasting algorithm. So it's going to be implemented in the next video, and then probably we'll go for the 3D projection. Okay, so this is it from my side. Thanks for watching. Until the next time, and take care.